Hello everyone, my name is Sairaj. I am from Institute of Aeronautical Engineering in CSC AML branch. My research-based learning topic is smart helmet for underground coal miners. Let's see one by one. So we'll cover all these topics. We will discuss all these topics. So let's see one by one. Industrial safety is one of the main aspects. Generally, if we see in the industry, when we are working in the industry, the safety is the first motto because without safety we can't do work efficiently. So in mining industry the safety is very important. So like there are so many accidents are happening in the mining industry, like roof collapsing, gases, did explosion of gases, and many other um, regions. There are so many accidents are happening in the underground coal mines. So to prevent this, so we need to prevent these accidents by implementing some technologies or some devices or safety measures. So topic is to my motto is to develop a product that is IoT product which will detect the underground gases and send it to the data will send it to the base station. The mining industry first runs on the safety first, and there are so many accidents are occurring in the underground coal mine. So to prevent this, uh, I have created a smart helmet for the protection of our mining workers, and it will detect the real time monitoring of harmful gases like CO, CH4, LPG, and temperature. So to develop this, I have referred some of the papers that are IoT based smart helmet for underground coal mines, smart helmet for coal mines safety monitoring and alerting, coal mine safety monitoring and alerting system, and these another three these paper I have referred. So before this IoT device, there are some existing methods to check the temperature or to detect the gases, to take the values of humidity from the underground. So these are the some of the devices that are existed, and this is architecture of the smart helmet for underground coal miners. Basically, there is a Arduino, and we will connect all the sensors to the Arduino, and connect we will connect to the Zigbee trans receiver and LCD voice module and speaker power supply. We will give the power supply to the Arduino to work this. So we require some of the hardware components as well as the software components. So let us discuss first hardware components that are required to develop this project. There is first Arduino Uno with 80 mega 328 pin microcontroller, ARP33A3 voice module, MQ2 sensor, MQ3 sensor, MQ6 sensor, DHT22, Zigbee transceiver speaker, and 16:2 LCD. And we require software used in this project for uploading code onto Arduino is Arduino IDE. We use Arduino IDE to write the code and to insert the code into the microcontroller. That is Arduino. The Arduino Integrated Development Environment is an open source software application that enables user to write and upload code to Arduino microcontroller board. It provides a simple and user-friendly interface for programming, debugging, and uploading code into Arduino board. The Arduino IDE is cross-platform and we can use in the Windows, Mac OS, or Linux. And it will support a wide range of programming languages like C, C++, and Additionally, IDE can be extended with third parties, libraries, and plugins to add functionalities and features to the software. Overall, the Arduino is an essential tool for anyone interested in building and experimenting with electronic and electron microcontroller. So we use mainly in this, we use the Arduino IDE to write the code and to upload the code into the Arduino microcontroller. So we will give some, we will give the connection so that it will detect and send it to the base station. So we will first, the smoke sensor will be connected to A1 port of the Arduino, and alcohol sensor will be connected to the A1 port of the Arduino. Gas sensor will be connected to A2 port of the Arduino. Humidity and temperature sensor, that is GHT, is connected to 8 pin of Arduino. So after that, LCD will be connected to A4 and A5 pins of Arduino with two wires and VCC with 5 volts and ground with GD. This is ground. Arduino will be connected to 3, 4, 5, 6 pins of voice module, smoke, temperature, alcohol gases, and Zigbee transmitter will be connected to first pin of the Arduino and also to the TXS. Methods of working. We will connected all the devices in the given pattern like this, and after connecting, how it will be work. So let's see. Helmet unit consists of smoke sensor, as we have discussed already in the hardware components, and alcohol sensor and gas sensor, temperature and humidity are connected to Arduino. Already we have connected these sensors to the Arduino. These sensors are available in the helmet to collect the temperature, humidity, and smoke. The elements in the air sample collected by the sensors will be broken into ions by using the heater. These ions forms a bond with the chemical used in the sensor. During this bond formation, energy released will be used to transmit the data collected to the Arduino. Arduino will be connected to the voice module and also to the LCD. The information collected regarding the gases, smoke, and alcohol gases by voice module through Arduino will be transmitted to the speaker, which will give audio alarm. The data about the temperature and humidity will be sent to the LCD, which give visual alarm. The power supply will be given to the Arduino and the data collected will be transmitted to the surface station for real monitoring through Zigbee transmission. Let us understand it by the how it will be worked using this understandable flow chart. First, we will start. We will give the power supply and helmet removal sensor. We will see for the helmet removal sensor. If the candidate, if the minor wear the helmet, if the minor wear the helmet, it will go like this. If in case if the minor doesn't wear the helmet, it will give the buzzer alarm. Let us take the consideration minor wore the helmet. We have connected the sensors like M2, MQ6, and all the sensors and hardware analysis. It will analyze the hardware and receive data from hardware and send information to the base station. And if the values are above the threshold value, it will give the buzzer alert and it ended. What are the advantages of the smart helmet? We'll discuss now. Smart helmet is of continuous monitoring type. So it will continuously send the data. After collecting the data, it will send to the base station. It is continuously sending the data to the base station. So it is a continuous monitoring type. It is a personal protective equipment. So why we call it this is personal protective equipment? It will detect the gases instantaneously. So we will prevent the accidents by by knowingly. So it can be easily carried out by every person. Every person can easily understand with the instructions of smart helmet. Base station helps us to communication regarding the results of ventilation survey from underground and surface. All the ventilation surveys can be carried out by the single smart helmet. It can take less time with the greater accuracy, low cost and easy portable. Some of the limitations are there. Let's discuss that. All the existing ventilations are of not continuous monitoring system. These devices are not personal protective type. This survey is only carried out by the supervisor. Not all the workers have complete knowledge regarding it. There is no communication between the surface and underground regarding this ventilation survey. The number of ventilation devices are carried out to carry out various surveys. It consumes more time with less accuracy. Applications of smart helmet. So where we can use this smart helmet, let us see. It can be used in any degree gas mines. It can be applicable at any weather conditions. It can be used to detect the smoke when it is a range of 300 to 10,000 ppm parts per million. It can be used to detect the alcoholic gases when they are in the range of 0.05 mg per liter to mg per liter. It can be used to detect the inflammable gas when there is in the range of 200 to 10,000 ppm. This is see we can see the prototype how we will how it will be seen like this is the speaker, this is the Arduino board, and this is the LCD. We have connected all the these are the sensors, and we have connected the sensors to the Arduino board. So sensor collect the data and send it to the Arduino, and Arduino process the data. If the value, the threshold value, if the value existing is above the threshold value, then the visual and audio alarm will be given. Conclusion. This system provides a wireless sensor network for monitoring real-time situation of underground mines from base station. It provides the real-time monitoring of harmful gases like CO, CH4, LPG, and also temperature and humidity. This system uses Arduino technology for transmission of data from underground mines. This system provides Arduino and visual alarming system. Future scope. Let us discuss now future scope. Preventing major accidents. By using this smart helmet with gas sensor, we can prevent the major accident by alerting system. Storing in database. It can help in storing the gas sensing value into the database so that it will automate the gasiness value record. Basing on the next, providing the temporary gas mask. Basing on the recorded value from the sensors, the gas mask will be activated. If the threshold value increases the gas mask, it will be activated. Power supply cutoff. If the gasiness value increases the threshold value, the power supply should be automatically cut off in underground mine to prevent the mine accidents. Thank you.